Okay, hello everyone in a new video. So we have reached part 4 of chapter 6, which is the chapter of AC voltage in the second unit of electricity. In this one we are going to complete solving exercises. Then we have reached exercise number 8 in section 19. They are telling me the waveform of document 1. They mentioned document 1. Now we can use it. Represents the variation of the voltage of the mains U delivered by EDL, electricity of Lebanon, as function of time. So now if we refer to the graph, we know that always a graph in physics, or the axis of the graph, is labeled by physical quantity. So the y-axis is labeled by the voltage U, as indicated here, and this is labeled by the time t, as indicated here. Okay, because millisecond is the unit of time and v is the unit of voltage. Moreover, if we refer to the title of this curve, they are telling me the variations of the voltage U. So the first variable coming after the variation represents the y-axis, and the second variable represents the time. Now the trick in solving such type of exercises is to extract the values of x and y, knowing that any curve represented in a plane is represented by a point having two variables x and y. So what does x represent? X represents the number of divisions between two consecutive peaks. So if we choose these two peaks, in this case we have 1, 2, 3, 4, so x is equal to 4 divisions. As for y represents the number of divisions from the center to the maximum point reached by the curve. So now we will choose this one because we have a dotted line. So if this is 1, 2, 3, the dotted line is to tell me that this point corresponds. So this point has the following value on the u-axis, but notice that this dotted line is between 3 and the first subdivision, knowing that each subdivision is given by 3.2. So it is between 3 and 3.2, which means that it's given by 3.1 divisions. So this is regarding the values of x and y. Moreover, we can extract the values of SV and BB by referring to this scale. So SV, which is the scale along the vertical axis, this is given by 100 volts. Knowing that this corresponds to 1 division, so per division. As for VB, is the scale along the x-axis, which is given by 5 milliseconds. Knowing that this corresponds for 1 division. However, 5 milliseconds is not the SI unit of time. In order to convert from milliseconds into seconds, we simply divide by 1000. So in this case, this is equal to 0.005 seconds per division. And now we are ready to solve the problem. They are telling me number 1, referring to document 1. 1.1 indicate the type of the voltage U, which is delivered by the voltage of the mains. And by indicate itself, it means that we need to state with a justification. So notice that this voltage is variable with respect to time. It is changing. So since it varies with respect to time, and so notice that part of the curve is above the x-axis, which means positive. The other part is below the x-axis, which means it is negative. For this reason, let me write it's alternately and is alternately positive and negative. And between brackets, let's write the shape. So this shape is sinusoidal. Which means the type of the voltage is AC sinusoidal voltage. Now in 1.2 they are telling me show that the maximum voltage UM of U is equal to 310 volts. The maximum voltage is determined by SV multiplied by Y. The value of SV extracted here is given by 100 in the SI, and the value of Y is given by 3.1. Plugging this on the calculator, then the value of UM is given by 310 volts. So UM is equal to 310 volts. And here let me make the following side remark. So as we have seen at the beginning of this exercise, in order to extract the value of Y, it's a bit tricky. But here they have gave me the value of UM, which is directly related to the value of Y. So if you couldn't achieve this value, it means that we have extracted the value of Y wrong. Then we refer back, and knowing that this is given by 100 volts, we can simply ask ourselves what is the number that is multiplied by 100 to give us 310. So this is simply given by 3.1. Now in 1.3 they are asking us to calculate the period, which is given by VB multiplied by X. So here we can use either VB or SH. So this is equal to 0.005, which is the value here, multiplied by the value of X, which is 4. Plugging this on the calculator, then the value of VB of the period is given by 0.02 seconds. Then T is equal to 0.02 seconds. Now after we have extracted the value of UM and the period, we expect that later on they will ask us about the effective voltage and the frequency. And indeed in part 2 they are telling me to deduce, and by deduce it means that we notice the previous parts, the effective voltage U. So the effective voltage here is denoted by U, not U effective, which is equal to UM divided by radical 2. The value of UM we have determined is given by 310, and the value of radical 2 is 1.41. Plugging this on the calculator, then it's almost given by 220. Since UM is expressed in volts, so the value of U will be in volts. So the effective voltage is almost given by 220 volts. Now in 2.2, referring back to 2, it means that we need to deduce its frequency, which is given by 1 over the period. Now the period is given by 0.02. Plugging this expression on the calculator, then the value of the frequency is given by 50. Since the period is expressed in the SI, so the value of F will be in the SI, which is Hertz. Then the frequency is given by 50 Hertz. Now here we deduce that this source that we are using, the voltage U, is AC sinusoidal of a frequency 50 Hertz, and an effective voltage U is equal to 220 volts. Now in number 3 they are telling me on the rating plates of 2 electric devices we read the following inscriptions. So we have 2 devices, device A and device B, that carries different inscriptions. Now what does these indications represent? Rated voltage, under which device A and B function respectively, as well as for the frequency and as well as for the type of voltage. So notice that both of them function under an AC sinusoidal voltage source. However, device A functions under a rated voltage or applied voltage 110 volts and 60 Hertz, whereas device B functions under an effective or applied voltage 220 volts and 50 Hertz. They are telling me choose with a justification the electric device that can function normally when it's fed by the voltage U. Now in order to describe the functioning, or to determine which device functions normally when fed by U, we need to compare these indications with that of the generator U. So notice that the indications of device B agrees with U. So let me say that since the applied voltage, and here whenever we need to discuss the functioning of device under AC voltage, we always consider the effective voltage and not the maximum voltage, because it is the one that makes the effect. Since the applied voltage is equal to the rated voltage, which is given by 220 volts is equal to 220 volts. But the voltage alone is not enough. We need to consider also the frequency. And of same frequency. Which is given by 50 Hertz. So let me here say same frequency. And of same type, which is given by AC sinusoidal. Then device B functions normally when fed by U. So this is it for exercise number 8. Let's move now to the next exercise, which is exercise number 9. In order to determine the characteristics of the voltage U delivered by generator G, we connect the terminals of G to an oscilloscope. Document 1, they mentioned document 1. Now we can use it. Represents the waveform of the voltage U. In absence of any voltage, the horizontal luminous line passes through the center of the screen. So we have seen this statement in the case of DC voltage. So always we need to calibrate the oscilloscope before we use it. Now they are telling me the settings of the oscilloscope are, so SV is equal to 5 volts per division, whereas VB is equal to, now notice that millisecond is not the SI unit of time. In order to convert from milliseconds to seconds, we divide by 1000. So this is equal to 0.005 seconds per division. Now, before we start solving this exercise, so as I have said previously, the trick in solving such type of exercises is to extract the values of x and y, because any curve plotted in a plane is described by two values given by x and y. So in this case, x represents the number of divisions between two consecutive peaks. But notice that here in this case, counting from the peaks is a bit tricky. So let's count from the center. Then let's choose a point. Skip a point, choose another point. In this case, it's given by 1, 2, 3, 4, 5. Sorry, let me make it clear. 1, 2, 3, 4, 5. So x is equal to 5 divisions. As for the value of y, it is from the center to the maximum point reached by the curve, which is given by 1, 2, and 3. And now we are ready to solve the problem or the exercise. They are telling me indicate the type of the voltage U, and indicate it means that we need to state with a justification. So notice that it is varying with respect to time. So let me say, since it varies with time, sorry, let me say with respect to time, and is alternately positive and negative. So why it's alternately positive and negative? Because part of the curve is above the x-axis, which means it's positive. Part of the curve is below the x-axis, which means it is negative. Okay, so this is positive and this is negative. And the shape of the curve, this shape is known as sinusoidal. Then it is AC sinusoidal voltage source. Now in number 2, they are telling me referring to document 1, 2.1, determine the maximum voltage UM of U. And UM is determined by the following formula as V multiplied by Y. No need to construct the triangle of this formula because this is the quantity that we are interested in calculating. So the value of SV is given by 5. The value of Y is given by 3. So this is given by 15 volts. Then UM is equal to 15 volts. Now in 2.2 we need to determine the period T of U, and the period is given by multiplying X by VB, which is equal to 0.005 multiplied by the value of X, which is 5. Now plugging this on the calculator, then the value of the period is given by 0.025 seconds. Then the period P is given by T, 0.025 seconds. Now as expected, because we have determined the maximum voltage and the period, we will be asked about the effective voltage and the frequency. Indeed, they are telling me deduce the effective voltage effective of U. We know that the effective voltage and the maximum voltage are related by the following formula. So the value of UM is given by 15. Notice that they didn't give me the decimal value of radical 2. So we keep it as it is and plug it on the calculator. Then in this case the effective voltage is given by 10.61 volts. Then U effective is equal to 10.61 volts. Now as for 3.2, they are telling me to deduce the frequency, which is given by 1 over the period. Now in this case the period is given by 0.025. Plugging this fraction on the calculator, then the value of the frequency is given by 50. Since the period is expressed in the SI, so the value of F will be in the SI, which is Hertz. Then the frequency is given by 40 Hertz. Now let me make some space here. And let me write down, because probably we'll use it here since I have noticed that we have indications. So let me say that U effective is given by 10.61 volts and the maximum voltage that we have determined earlier is given by 15 volts. Now in part 4 they are telling me a lamp L carrying the indications 15 volts and 9 watt is connected across the terminals of G. In 4.1, what does each of the indications carried by L represent? So let's start by 15 volts. It is the rated voltage of the lamp L under which it functions normally. Now as for 9 watts, watts is the unit of power, so this is the rated power. Consumed by the lamp L under which it functions normally. So this is it for part 4.1. Now in 4.2 they are telling me the lamp glows weakly. Justify, and the glows, which means shines, refers to the functioning of the lamp, because we know that light transforms electric energy into light energy. So the lamp lights up. Now in order to describe the functioning of the lamp, we need to compare the applied voltage to the rated voltage. So the rated voltage is given by 15. So for example here, if you consider the maximum voltage is equal to the rated voltage, so the lamp will glow normally. However, in order to describe the functioning of a lamp and connect it to an AC, we need to consider always the effective voltage and not the maximum voltage, because this is the voltage that makes the effect. And notice that in this case the applied voltage, which is given by 10.61, is less than the rated voltage, which means it will function weakly or not function. Since here they are telling me glows weakly, then we will restrict our answer to this option. Since the applied voltage is less than the rated voltage of the lamp L, and this is because 10.61 is less than 15. Then the lamp glows, let me say the lamp L glows weakly. Now in 4.3 they are telling me calculate the electric current that should reverse the lamp in order to glow normally. And by glow normally it means that the applied voltage and the power consumed is equal to the rated. So the indications are given by voltage and power. Whenever we know two indications, the third can be determined from P is equal to U multiplied by I, knowing that you are interested in determining the value of I. So constructing the triangle of this formula here, because we have multiply, then P will be at the top, U and I at the bottom. Putting our hand over I, then the value of I eventually is given by P divided by U. The value of P is given by 9, whereas the value of V is given by 15. Plugging this on the calculator, then the value of I is given by 0.6. Since P and U are expressed in the SI, so the value of I will be in the SI, which is amperes. Then the value of I is given by 0.6 amperes. Now this is it for exercise number 9. Now let's move to the final exercise in this video, which is exercise number 10. Section 21. A water heater is formed of a water reservoir equipped with a resistor D of resistance R. Now 1.1, they are telling me the resistor D transforms the electric energy received into another form of energy. Give the name of this form of energy. We know this is given by the thermal energy, which is known as the heat energy, because there are two main roles of the resistor: to limit the flow of the electric current or to transform thermal energy. Okay, the resistor perform both roles, but here we are interested in the thermal energy. Now in number 2 they are telling me the characteristic current voltage curve of the resistor D is one of the two adjacent graphs of documents 1 and 2. So they mentioned documents 1 and 2, now we can use them. They are telling me in 2.1 the graph of document 1 doesn't correspond to the characteristic of D. Justify. So notice that the curve which is being plotted in U versus I represents the signature of the electric component. And we know that in the case of the resistor, the shape of the curve is a straight line passing through the origin. This is the straight line passing through the origin, so this is the resistor. However, this doesn't correspond for the resistor because notice, although it's passing through the origin, but it's not a straight line, which should justify the fact that document 1 doesn't correspond to the characteristic of D. What is the characteristic of D? It is a resistor. Since the characteristic current voltage curve of document 1 is not a straight line, then graph of document 1 does not correspond to the characteristic of D. Now in number 2.1, so after we have eliminated the choice that this corresponds to D, we are left that this corresponds to D. They are telling me show using document 1, sorry, this must be document 2. That R is equal to 50 ohms, so we need to determine R graphically, and this can be done using the slope method that consists of several steps. The first step is to write the definition, the resistance of the resistor, is equal to the slope of the characteristic current voltage curve full point. Now the next step is to choose any 2 points belonging to the curve. So I will choose this point and this point. Now notice that the point A has coordinate 0.1 amperes, 5 volts. We always start by the current then the voltage. So the point A is given by 0.1 amperes and 5 volts, whereas for the second point, which is given by 0.2 amperes and 10 volts. And notice that in this case, A and B are expressed in the SI, so no need to convert. Then we can skip step 3 and directly write that R is equal to UA minus UB divided by IA minus IB. Now the value of UA is given by 5, the value of UB is given by 10, the value of IA is given by 0.1, and the value of IB is given by 0.2. Plugging this complicated fraction on the calculator, then the value of R is given by 50. So how do we know that this is the voltage? Because it carries the unit volt. This is the current because it carries the unit current. So I have replaced them here. Since everything is expressed in the SI, so the value of R will be in the SI, which is ohms. So R is equal to 50 ohms. Then in this case, this is verified. Let me make some space. Now we have reached part 3 and they are telling me the water heater functions normally under an alternating sinusoidal voltage of effective value U is equal to 220 volts. So the moment they give me the effective voltage, so we deal with it as if it was a DC voltage source. Now in 3.1 they are telling me show that the expression of the electric power consumed by the water heater is given by that. So we need to prove the following expression. And in order to prove the following expression, we always start from the general form, which is given by P is equal to U multiplied by I. Now comparing both forms, the connection, which is R, and this is given by Ohm's law, knowing that in this case if we compare both, it means that we need to get rid of I, which is given by U divided by R. Plugging this expression here, so it's equal to U multiplied U divided by R, which is equal to U times U divided by R. Here we are multiplying two fractions in the form of A over C multiplied by D over D, in this case A is given by 1. This is given by U square over R. Then prove that P is equal to U square divided by R. Now in the same part they are telling me deduce the value of P is equal to 968 watts, and by deduce it means that we need to use the previous part. In the previous part we have proven the following form, and if we refer to the previous calculated values and the given, we have that the value of R and U are given by the following. Then in this case P, which is equal to U square divided by R, the value of U is given by 220 and the value of R is given by 50. Plugging this expression on the calculator, then the value of P is given by 968. Since both U and R are expressed in the SI, so the value of P will be in the SI, which is watts. Then the value of P is given by 968 watts. Now in 3.2, they are telling me calculate in kilowatt hour the electric energy consumed by the water heater during 5 hours of functioning. The moment they mention kilowatt hour or kilowatt, it means that you are interested in determining the electric bill, which consists of several steps. Let me write step number 1, which consists of converting P to kilowatts. Step number 2 is to calculate E1 for 1 day. Step number 3 is to calculate E for month. And step number 4 is to calculate the cost, which is the price. So here they are telling me to calculate the energy in kilowatt hour consumed by the water heater during 5 hours of functioning, and 5 hours represents the amount of energy consumed per 1 day. So they are asking me about step number 2. In order to determine step number 2, first we need to proceed with step number 1. The power, which is given by 968 watts, should be converted to kilowatts. So 968 divided by 1000, this is equal to 0.968 watts. Kilowatts. Why? Because in order to convert from watts to kilowatts, we divide by 1000. So the power is given by 0.968 kilowatts. Yet we didn't answer the question because we are asked to determine the electric energy, which is given by E is equal to P times T. Since this energy corresponds for 5 hours, which is 1 day, so let's place the index 1 here. Now kilowatt hour is the unit of energy, which is decomposed into kilowatts multiplied by hour, which means power must be expressed in kilowatts, which is given by 0.968. As for T, which is hour, which is given by 5. Plugging this on the calculator, then the value of electric energy consumed in 1 day is given by 4.84 kilowatt hour. So E1 consumed for 1 day is given by 4.84 kilowatts hour. And eventually in this case we are done with the steps number 1 and 2. Let's proceed. So we are in part 4. This is given by 4.1 and 4.2. Calculate so the water heater functions for 15 days in a month at an average rate of 5 hours daily. So 5 hours daily represent the number of hours for 1 day. Although it is 24, but the actual quantity of hours functioning or number of hours functioning is given by 5 out of 24. Now, although the month consists of more than 15 days, but 15 days represents the actual days per month in which this water heater functions. In 4.1, they are telling me to calculate the electrical energy consumed by the water heater during 1 month. And we are asked for step 3, which is given by E. So here we are talking about the monthly consumption. Which is given by E corresponding for 1 day multiplied by the number of days, which is equal to E1, which is equal to 4.84 multiplied by the number of days, which is given by 15. Plugging this on the calculator, then the value of electric energy consumed for 1 month using this water heater for 1 month is given by 72.6 kilowatts hour. Then E is equal to 72.6 kilowatts hour. Now in 4.2 they are telling me to deduce the monthly amount to be paid by the consumer, knowing that the average cost of each kilowatt hour is 100 Lebanese liras, and by deduce it means that we need to see the previous part. In the previous part we have determined the monthly consumption, so the monthly cost is simply multiplying the monthly consumption. So let me say the price. So the month, so okay, E multiplied by the cost, which is equal to 72.6, multiplied by 100, which is equal to 7,260 Lebanese liras. Okay, so this is the monthly amount to be paid by the consumer when using this water heater for 15 days and each day 5 hours. Okay, so that's it for me in this video, guys. In part 5 we'll complete solving exercises on this chapter.